Good morning. I'm Pei Pei Chen from Yokozuna Data. And I'm machine learning lead in Yokozuna Data. And I am here presenting on behalf of our CEO and founder, Africa Pleianius. I have been working with her since the very early beginning stage of Yokozuna Data. And I will be here sharing our milestones, our visions, and the revolution we believe is going to happen because of machine learning technique applied to extremely rich player behavior data. So my title today is Future is Written in the Data, Anticipating Player Behavior with Machine Learning. Let me introduce myself again. I'm Pei Pei Chen, machine learning engineer lead in Yokozuna Data, and I'm currently leading the whole production development of Yokozuna Data. And my background is computer science. Before joining Yokozuna Data, I was doing research in National Informatics Institute in Tokyo. And this is one of the most famous computer science research center. And I was doing signal processing research and other signal data retrieval research there. So this is basically my daily job in Yokozuna Data. As I just said, I'm leading the whole machine learning into production pipeline, from collecting data of our customers and big data infrastructure, machine learning algorithms, to the data visualization to the customer, from marketing people, game developers, planners, different kind of customers. Okay. So what is Yokozuna Data? Yokozuna Data is founded in 2015 by our current CEO, Africa Pleianius. It was founded actually in Silicon Studio, a game studio in Tokyo, which is a spin-off of Silicon Graphics. And when Africa first joined this company, she was very surprised that there's almost no machine learning, there's almost no data science utilized in this industry, even if game studio is only an amazing data set of player behaviors. So she started a project, and we are doing a general behavior machine learning model to solve video game business problems. Why we emphasize general here is that our model can be automatically applied to different kinds of games. We have been working with Western casual games or large-scale MMORPG. And the models adapt automatically to different kinds of player behavior, playing styles. And our ultimate goal will be to personalized games. So what is our mission? As I just mentioned, when game studios is only an amazing data set, they are not looking into it. So we want to unlock the knowledge, unlock the players' secrets, players' needs from the rich data set. And most important thing is that to convert this data into actionable information. So based on what we predict, based on our resource, Game Studio can do extra actions on it, can try to retain the user or design the personalized strategy to engage each different kind of users. And all our prediction is done individually. So every single user, we know what they need, we know what their preference is. Let me show a little our team. This is our team. We are quite international. We're gathering experts from all over the world. Our backgrounds are computer science, also mathematics, physics, and statistics. So we gather people from around 10 countries, and we have, I think, 4 or 5 Spanish in our teams. In our team, we have machine learning engineer, we have data scientist, we have big data infrastructure engineer. Hello? Great. Thank you. So every people take care of different part of machine learning model into production. If I am asked to summarize how Yokozuna Data distinguishes from other service, I would like to summarize these 5 keywords. So first of all, interdisciplinarity. As you have read in our team members, we believe in interdisciplinarity a lot. We are taking robust machine learning models from other fields, like medical, mathematics, to solve video game business challenges. And also, we have very strong connection with academia. We are constantly publish lots of papers. We attend conference to make sure that we are updated and we are the state of art in this field. And also, we work like a startup, execute fast, and adapt to new technology flexibly. So after a short introduction of ourselves, I would like to start discussing about AI and game. So this is an example. Two nature covers here is showing that games are not only entertainment now. Games data and games themselves are becoming a very good material for AI research. Games are the perfect proving ground for developing and testing AI algorithms. Demis Hassabis, the CEO of DeepMind, said. And we have a similar but a little bit different vision. We think that games are the perfect ground for understanding human behavior. You may still remember the Go gameplay between AlphaGo and a top player in 2016. Actually, Go is a very complicated game that even top player cannot explain their start strategy, cannot explain why they do this move. But AlphaGo was able to make a huge success by training reinforcement learning models fighting with each other. Then we want to do it now in another direction to understand deeper not only how to win the game, but also how top players, how AI make the strategy, how they think, and what's the motivation to play the game. As you may know, video games are like small worlds. In video games, we are doing in-app purchases. We are interacting with other players. We are also facing different kinds of challenges, just like our daily life. But what's different between video game worlds and the real world is that in video game studios are recording each action you are taking. We are recording and saving every purchases, every task, every level you pass, and every decision you made into our database. So with this database, we can understand well your personality, your emotion, and your preference. So it sounds amazing, but how can it really solve video game industry challenges? Yokozuna Data is focused in 3 parts. The first part is player retention. How do you design a personalized engagement, a personalized strategy to increase the engagement and increase the retention rate of every single different user? Secondly, is game optimization. I think most of the game studio nowadays is doing lots of different kinds of events, and they also do marketing campaign. But what is the best point to start this event? What is the great time to start the marketing campaign, and which kind of event will attract your user the most? And the third point is game development. What we are trying to do is to optimize the development of game. By analyzing data, we know what do your players like and what they don't, and which level is too boring, which level is too difficult. So as I just said, all of our data scientists and engineers come from different backgrounds. So when we jump inside game industry, we're actually quite surprised that while other industries are doing personalization, game industry is almost doing nothing on personalization. So as examples, Spotify is providing individual playlists with your previous data. And also, Amazon recommend your product by your previous purchase log. And also, Netflix is selecting films based on what you have watched and your preference. And even Google is providing individual search results based on where you are and your previous searches. Then, how can video games work with personalization? This is the first example I would like to mention. Personalized matching. Which clan is your best opponent in Clash of Clans? Who should you compete against in Mario Kart? So, no matter you are a more aggressive racer, or you want to just enjoy the game without computation, our algorithm can learn automatically from your previous behavior and recommend you an opponent which let you enjoy the game most. And here are more examples. Personalization can also help the engagement and retention motivate users and retention them by actions recommendation. So we have item recommendation system. We have action recommendation system. So by this system, integrate with your game server, we can automatically provide you strategy to engage and retain your users. And also, when we talk about sending personalized rewards, sending personalized coupon to users, a pricing model is also an important thing to taking care of. So here are several machine learning models which we have put inside our production. The first I want to mention is we know when a player will leave the game since the very beginning day they join the game. So when they join the game for the first day, for the second day, we foresee that this user is going to live in 97 days, for example. And we know which level. And also we know how many hours after they play, they start get bored. And we know which action they will perform in the future. And we know which item they will purchase and when they will do their first purchase. This is the information of, this is an example of utilizing item recommender. As you see, we are importing the building history and playtime history, also other things like action history, social interaction history, every different clicks inside our model. And in the end, we get something like this pie chart. We know the distribution of item probabilities. For example, this user wants to buy this treasure chest the most. And after we know this user is going to buy this treasure chest, how can we do action with these prediction results? Is that when we realize that this user is going to leave soon, if we realize that this user is going to leave in 30 days, and we think this user is very valuable, we can start sending them this treasure chest for free, or we start sending this coupon. And this can motivate this user again and prevent the churn. Sorry. Okay. But actually, for many games, especially for larger scale MMORPG, they have more than 100 items. And this is very confusing to machine learning model. We cannot just put inside at once more than 100 items. This will let machine learning model learn nothing or learn very bad results. So we have proposed a brand new machine learning data science algorithm to deal with this kind of problem. So for games with hundreds of items, we do a dimensionally reduction first to group the item in several groups and put only the group inside the models. So after the model learns about the group, learns about the probability distribution, we map back again from group to single items. So this algorithm helps us do operational in-game item recommendation to individual players efficiently, accurately, even for extremely large-scale games. So not only about in-app purchase an item, as I mentioned before, how to do game events in the right moment is also an important topic for game studios. So we are also recommending the optimized game sequence for every customers. We tell them which events they should do to optimize their sales, to optimize the player engagement. So in this model, why we are very accurate is because we are taking care of not only in-game behavior, we are taking care also external information which affect player behavior. First of all, weather. Whether it's sunny or raining, or whether it's very hot or not. Let me take an example which is very easy to imagine. If you are playing Pokemon Go and it's raining outside, then obviously the engagement of players will get decreased. So now the game studio need to decide another event to improve it. And also, we're taking care of special days, and it's fully localized. Like if we are working with Chinese customers, we input Chinese New Year. And if we are working with European customers, we can improve Christmas. And also sports events, which is very important, is also input, and also the holidays, like summer vacations. So after talking about several approaches, what are we going to solve? I want to focus again back on what the video games challenges we are really facing now. And we believe that predicting user behavior is the key to solve these challenges. The first challenges I like to mention is increased retention. So as you may have noticed, especially for free-to-play games, there are around 90% of users just download the game and leave. And also, after 1 month, there are only 5% of the users still remaining in your games. But this is extremely inefficient because acquiring new users is very expensive. You need to pay for commercial, you need to pay for marketing to get user. But if you don't retain them better, they leave your game at the first day. Especially for users who pay. There are 10% of paying users, most of the time contribute around 60% of your revenue. So how to understand your user better and retain them by their previous behaviors is a very important topic. And the second challenge I would like to mention is how to maximize the engagement of VIP player. Because this is related to lifetime value prediction, related to predict how much money the user will still spend. I will explain more technical detail about this later, but predict the lifetime value of users is very important because we can take action beforehand. If we foresee that this user is going to spend 1 million more, then you don't want to lose the user, and you want to provide them more premium service in their earlier stage. And even if you foresee this kind of user are your potential paying user, you can design different strategy to induce the in-app purchase. And the last challenge I would like to mention is to optimize game events and marketing campaigns. After working with many customers, we realized that most of the studios are designing their game events by their intuition, by their experience. Then why don't you let data science, why don't you let machine learning to help you? We know what is the best point to start the event. We know which kind of event is the best. And even more, after all, we can review your events and tell you why this event didn't go well, or why that marketing campaign didn't attract as many users as you expected. So, if we solve these business challenges, how much revenue we can gain, how much impact we have if we really solve these challenges. We did several scenarios based on the data we have. So this is the numbers for AAA mobile game. If you increase 10% retention of your VIP users, only 1 month, not the whole lifetime, you increase only the retention for 1 month, you can get 1.3 million revenue more. And if you increase the paying user for 5%, you are increased 4 million sales. And if you are improving the most boring levels, you expect to get 8 million a year. Again, this is the numbers for AAA titles. And what should be the number for Western casual games? You can see also significant improvement if you improve the VIP retention and PU increase. But what worth to mention here is that you can see if you improve the development of the levels which is more boring, which is not so interesting, you get even more sales increase than AAA titles. So this tells a story that rather than the very well-designed AAA titles, actually the casual games is having lots of space to let data science, to let machine learning help to improve their game design. So with all of these techniques, we provide a solution. Our solution is an operational player behavior prediction platform. What is operational means here? It means that it's their updated result for 7 days, 24 hours. Every time you want the latest result, you just log in to our platform and check. And also, our platform is fully integrated with with Game Studio's server. So if you want to send a coupon, if you want to send an item, send a push notification, all the things can be operated in our platform. So let's directly take a look at a live demo of our platform. Okay. This is the dashboard of our platform. As I just said, it will be updated always for you. And this shows the summary and show the overview of your current game status. For example, you can see today's sales focus and this month's sales focus and your survival status of your users, like how many users will leave in 10 days, how many users will leave in 3 months, and also what is the best event sequence for you next month to optimize sales, optimize playtime, and the level you need to improve, and also other basic information like the new users like this. So let me go through directly to the most interesting part in our platform. We have lots of tabs, but I want to show the most the prediction part. Okay. So this is the survival prediction page. Every number is the user's ID. Hello? Yes, great. So you can see lots of users here. For every single users, we know their current sales, of course, and we know their future sales. This means the UPP means upcoming purchase prediction. So for example, this user is going to spend 40K more. And we know the survival probability, some user may churn very soon, the survival probability would be very low. So after knowing this information, what can you do? You cannot check one by one and decide because you don't have so much time. So now here we group the users for you. For users who will leave the game in 9 days, maybe you want to directly send them another advertisement of your another game title in your studios. So directly you send here push notification. You input the message you want to say, and you send, and the user will get the message at the right time. And for users who will leave in 30 days or 90 days, we want to send them coupon. We want to send them their favorite items. But which item should we send? We cannot send everyone the same item because maybe some users are in very high level, some users are in very low level, or they want different kinds of items. So that's why we are also doing item recommendation. So our item sending system is fully connected to our item recommendation system. This is our item recommender. You can see here is also by every individual user. So every individual user, you know what is the possibility they will buy a certain item. So let me take this for example. This user want to buy item 6 the most. And this user want to buy item 5 the most. So when we realize that the user is going to leave the game and the user is going to spend still lots of money, we can start sending in special gift. And as I mentioned for many times, we recommend the optimized game events, but we also have a tool to help you decide which kind of game event you should do. So this is a simulation tool. You can input the event you want to do. Like I want to do a promotion campaign here. I want to do a gacha, a lot of gacha. And gift event here, for example. And we press run. So after 10 seconds, you will see this number change. You will see if you do this event next month, how much will be your sales, and how many hours will be your total play time. So this is useful when you are hesitating that maybe I want to go for this event scenario, or I should go for another. So this will be a very useful tool for game studios to decide what kind of event, what kind of marketing campaign they should do. Another useful tool I would like to mention is playing habits. So as I just said, we automatically send items. We automatically send a notification to players. But what is the time we need to send? For every single user, we know when should we send. Sorry, maybe internet not so well, so we cannot see the whole page. But actually, there will be a list of users, and you know this user is most of the time active at 7 a.m. And that user will be active at 9 a.m. So when we want to send notification, the notification arrives when they are tend to log in. Because this is very bad when you are a salaryman, you are working in the morning and you get event notification, but you cannot do nothing. So our system prevents this problem, always send a notification, always send the item at the right moment. And we still have a lot different kinds of analytics and prediction, but because I don't have so much time, so let me show the last one. So we are analysis also different levels. What is the level who your paying user churn the most, and what is the level who induce the sales, and when the user do their first purchase. So by this, hello? Okay, I have it. So by this information, we can know which level we should improve. So after a quick live demo, let me go back to the presentation. Great. So, as I have said, we made an operational player behavior prediction platform. But how did we make it? Let me go through very quickly about the technical details. We have the two main techniques to help us develop this system. The first part is data science part, deep learning and ensemble learning, and also other models. And the second part is big data part. I will explain it one by one. So the first technology we are using is ensemble learning. I won't go through the detail now because it will be very long. But the basic idea of this model is to combine the prediction, combine the results of many different smaller models, many different smaller classifiers. So by combining the results of many classifiers, the results can be less biased, can be more accurate. And the second machine learning technique we are using, maybe you can imagine, is deep learning. Deep learning is a very hot word now in many different kinds of industry. And once it's machine learning related, everyone is talking about deep learning. It sounds very trendy, but actually, the basic idea of deep learning was already proposed in the 40s. But at that time, the computer is too weak. We don't have enough computation power, so it didn't get a lot spotlight. It's artificial neural network. And when it comes to 80s, even the computer becomes a little bit better, but we had many different kinds of other popular techniques like support meta machine and other machine learning techniques at that time. So recently, deep learning become very popular again because of parallel computing by GPU and because of distributed computation system now. So compared to artificial neural network, deep learning models have many layers which can learn more complexly combination, which can learn directly from all the user time series. Yokozuna Data is constantly doing lots of research because we believe that doing research is very important to update ourselves always and to provide a state-of-art machine learning model to our customers. We have published, I think, more than 10 peer-reviewed papers in IEEE top conferences. And these are only several examples. And I think I cannot go through all the paper, so I only want to talk about one. This is one of the most freshest one. I presented this paper last year, December, in Seattle. This paper is about lifetime value prediction for video games. This is a simple example why we need to do player lifetime value prediction. So as you see, these two players, the first player spent around 30K, but it will spend still more than 400K. But the second user, while the user have spent like around 90K, the user will still spend only 70K. By the way, this is Japanese yen, this is not euro, or it's too much. And when we realize that these two users are going to leave the game soon, their survival probability is very low, and we want to send items, we want to retain them, we can decide which item to send based on their future purchase prediction. And here is the data set we used to do research. And there are two main challenges to solve this problem. The first one is the various lifetime. For certain users, they may have more than 5 months of data, but for several users, they only have 1 or 2 days of data. But our models need to deal with both kinds of users. And the second challenge is the unknown turn day. We don't know when will the user leave the game. If the user is leaving in 7 days, maybe the user won't spend much. But if the user is leaving in 1 year, then the user will still spend a lot. But this is unknown, of course. So our models also need to take care of this kind of information. We have tried many kind of different models, like more classical models, Pareto distribution. But in the end, we decide that convolutional neural network, CNN, can be one of the best solutions for this model. Let me show a very cute cat picture, because maybe after technical explanation, you start feeling sleepy. So why we choose CNN? Actually, CNN is proposed in 1989, and it was firstly used to do image recognition, to recognize handwriting of people. And this is an example of how CNN do image recognition. The strength of CNN is it learned the local connectivity. It learned the pixel which next to each other. So you can see a square there on the cat's ear. And how this model learned? It moved the square as a moving window through the whole picture. And it learned this is eyes, this is ears, this is tails, and then it can tell that this is a cat. But we are not doing image recognition. Why we chose CNN in the end is because we have similar problem. What we want to identify, as we identify cat's ears, we want to identify the pattern in player behavior. So we did a by dimensionality reduction. We done the dimension of CNN from 2-dimensional image to 1-dimensional time series. And by this dimensional reduction, we can learn the patterns of player behaviors, and in the end, learn their future purchase. So this was the idea of this paper. And the last thing I would like to mention is a competition. This was a quite exciting milestone for us. We joined a competition which is hosted by NCSoft and hosted by IEEE in New York in 2017. And what is this competition about? Oh, by the way, the member of this competition include Anna Guitar, who is also from Barcelona. She is in Tokyo now. And myself and our CEO, Africa. So this competition is about 2 topics. It's about trend prediction. The first one is that which players will leave the game? Yes or no, binary classification. This one will leave, this one will not. And the second track is when will the user leave the game? How many days? This user 100 days, this user 272 days, this user 15 days. So how many days? Very detailed information. And in this competition, there are 264 teams joined from industry, top university, top research centers. And we are very happy to announce that we got top 1 in both tracks. And this model we are using is totally the same as the model we are putting into production. So it's a proof that says we are providing the most accurate model in the world to do trend prediction for video games. So this is the example output of this model. So for each user, we are providing a survival curve by level, by play time, and by lifetime. So each line is a user. The green line is a user who is very, very loyal. You can see, check the y-axis, the survival probability. The survival probability is never getting too low. And for a user who churn faster, like the red user, the survival probability will drop quickly. So we can design different strategy for different kinds of user by this survival probabilities curve. So after the data science part, I would like to also go through shortly about our big data infrastructure. Why big data infrastructure is very important in our project is because that our customers are actually uploading and transferring terabytes of data every day to us. And this is very heavy for a server. We need to do the computation very quickly, even if they have lots of data. So we have built a cloud distributed system which designed for data upload and data storage and also the computation part. This is the database we are using. It names Cassandra. Why we choose this database is because that is a distributed database which saves data in many different kinds of areas. We can save European data in Europe, and we can separate the data in many pieces in two different data centers. And this helps us to confirm the data security. We don't lose data because of one server is down. We don't lose data because of a server in China is on fire. So this is why we choose this Cassandra database. And also this database can scale up linearly. Once we have a new customer in another area, once we have more data from another customer, we just simply start a new node. We just simply start a new server. So this is how useful this Cassandra database is. And this is an overview of South system. It looks very complicated, but the idea is distributed system. Kubernetes is a tool we are using, which can let us to start a new server flexibly due to our need. So when there are heavier load, we automatically start a new temporary server, and when we have less load, we close the server. And we are also use Spark to do the parallel computation, and in the end, all the resources will be saved to the Cassandra cluster and served in our web server to our customers. So after quickly going through what we are doing, I'd like to come to a summary. So, as I mentioned, video games is facing lots of challenges on retention and also on engagement. And because all the players have different kind of tests, all the players want different kind of things. So, how to personalize the playing experience become a key topic in video game industry. And profile players at individual level will help you understand different kinds of player better, and also design a game events and decide when to do a promotion will save your investment, will help you optimize your game development better. And also to identify VIP user who will spend a lot in advance will help you provide them premium service earlier. And Yokozuna Data is providing solution for all these questions. So we are doing individual user actions recommendation, and we are personalizing the promotion and rewards by our prediction. And also we know what is the level the user will leave, and to help you improve the development of the levels. And we tell you what are your users with more potential. So that was my talk, and this is our contact. So if you have any question, you can also contact me or ask now. Thank you. Yes.
Do you have any questions for Pei Pei? Any questions that we can take? A couple of questions. So there's one question here. Can we get
my
Hello.
Hello.
Thank you for your presentation.
Thank you.
How much data do you need to provide useful results?
Okay, so it depends on different kinds of games. If your game is more casual, normally 1,000 or 2,000 users will be enough, and the time period will be around 2 or 3 months. So this is the low borderline for us. Yes.
Hello.
Hello.
Hey. So it actually is about that question also. If you have retention problems,
Yes.
how can you collect the data, like really like big retention problems, like your players leave after 7 days or 2 weeks? Is that even enough data for you to actually help?
Yes, it depends on how many users you have, but normally because 1,000, around 1,000 will be enough to us for analysis, and more than how long the user live in the game, we focus more on the whole progressing history of the user. So even if the user live in the game in 7 days, we know when is the point they leave, and then we can analyze the point. We can analyze different points from different users to acquire accurate result. So the lifetime of the user will not be the problem. The progressive in the 7 days will be more important for us.
Okay. Okay. Thank you.
Another question here. In front of you, Fred. Yeah. Thanks.
Hello. I know to be able to retain the users is key for the business, but don't you think that it can be a bit scary if you keep them hooked to a certain game?
I think for game studios, this is what they would like to do, but how I think you want to mention about addiction maybe, but actually how to utilize our data is on game studios' hands, because we provide our results and our results is neutral. And with this detailed behavior information, you can actually detect what user has potential possibility to become addictive. So if you want to undo, you can do different strategy to prevent the addiction behavior of different kind of users.
Regarding this question, when you have such an innovative technology, you always have like things you can do for good and you can do for not so good, right? Let me mention an example of a very interesting startup that is outside that you might be, you might have stopped by before. It's called Boctro Labs, and they are doing artificial voice, right? All the things around this kind of innovation, artificial voice is also, it can be misused sometimes, right? But I think the most important thing is they allow for new creative opportunities. And if you use it, you are the guys and the girls that have the creativity in your jobs, and if you use it right, you can make wonderful things in any case, right?
Yes, thank you.
Any other questions? Yeah, there's another question here. Oh, there is one there, and then there's another here.
Hola.
Yeah, thank you.
¿Se escucha? Hola. Hello. Here. In front of you. Yeah. First of all, I think the show you're doing is mind-blowing. So
Thank
congratulations.
Thank you.
It opens the door for doing a trillion things. I have a million ideas in my mind. My question is a little bit more about if you are making like gamer profiles or something that could help marketing team to understand players and then try to acquire players that will probably retain better.
Yes. So all our prediction and analysis is based on every single user. So for every single user, we can check the gamer's profile, and also we are doing clustering of user. So different kinds of group, this group of users love that kind of events, and that group of users like that kind of event. All the information will be included for marketing people to decide how can you achieve how do you increase the retention for certain kind of users?
Hi. So we've talked about personalization in the context of online games. Do you see potential to use this technology, these techniques in offline games, in single-player games?
First of all, we need data. So if the player play offline and you are not logging any data, it can be difficult. But if you play offline but you still log the data somehow, then no problem. If we have data, we can do the things.
So, hi. I have a question related to an European law that lets you know what data companies have from you. Does your platform provide some sort of function that lets you englobe all the data that you have from a single user and provide it to him in some sort of document?
Actually, first of all, we are not collecting any personal data. We don't know the user's names. We don't know where the user lives. Even we don't know the gender. So all the user, as you see in our demo, is a stream number. So I think we don't have this kind of problem in personal privacy.
Yes, one simple question. Who's the owner of the data?
Sorry?
Who's the owner of the data? Are you the owner of the data you are retrieving, or is the company the owner? Can you sell information that you retrieve from a company to another company, like Facebook does?
No, we cannot. So we save the data, and when they stop the contract, we delete it right away. And we even doesn't share the data between our customers. So yes, we don't have the right to use the data in whatever way.
One last question.
Hey, one problem you can get into when you're trying to do small changes to a game is get into a local maxima, where you think it's a summit, but actually the summit is somewhere else. How can you avoid that with the data that you have?
Okay. So in terms of prediction, we are choosing our model and validating them very intensively to prevent that we get the result of local maximum. And this is the cross-validation is done with many different kinds of games. So this problem won't happen. And if you want to talk about how do you develop game to prevent this kind of problem, I think we are providing also every testing technique. So in our platform, you can automatically start lots of different kind of testing and to realize what is the change, what will be the behavior change based on your edit in the video games.
Okay, so I think we're ready. We don't have time for more questions, but Pei Pei will be around, right, if you want to talk to her. Thank you very much, Pei Pei. It was a wonderful presentation.
Thank you.
Thanks a lot.
Thank you.